Here in chapter section 2-6, it's called special functions. And we are going to look at a couple of special functions, unusual functions, something that we don't necessarily deal with all the time. And we're going to start with piecewise function. Here in a few minutes, we're going to look at a greatest integer function or step function. But let's start here with this piecewise function. And so you might be asking the question, what is a piecewise function? Well, I'm glad you asked. So a piecewise function is any function that is written with two or more expressions. And it will have a constraint. It will have constraints associated with it. So let's look. Here we got f of x equals, and I see that I've got two expressions and I've got two constraints. One expression is x plus 2, and it comes with the constraint if x is less than 0. And then my second expression is just x, and the constraint is if x is greater than or equal to 0. Now we're going to move over to the calculator, and we're going to graph those. I'm going to show you how to graph and put in these constraints. To graph these piecewise functions. But one thing before we leave, if I look at that first expression, the constraint is if x is less than 0. Well, that's when I graph that, that's going to characterize an open dot when x is equal to 0. And in the second constraint, if x is greater than or equal to 0, that greater than or equal to, the equal to portion of it would have us use a closed dot. And one of the things that your calculator is not going to do, it's not going to define those open dots and closed dots unless you use the inequality function, but I'll have to double check on that. If that works, I'll show that on the calculator as well. So we're going to move to the calculator. We're going to graph these, putting in our constraints, and then we're going to end up identifying the domain and the range. Well, as promised, I'm over here on the TI-84 calculator. And before I graph these, I'm going to just do a couple of things. I want to make sure, but I'm going to just take a peek at my window settings. And they're in the default mode, negative 10, 10, x min, x max, y min, y max, negative 10, 10, scales of 1. And for what I'm going to do, that looks okay. And pretty sure I don't have my stat plot on, given what I saw on the graph when we came in there, which was a quadratic. But I'm going to double check it anyway. I'm going to hit the second, y equals, and my stat plots are off, so I'm okay. So I'm going to go back to, I'm going to go to y equal. And I'm going to clear out what I have in there. We're going to hit clear. All right, so let's see. Well, we're going to first graph the expression and then put in the constraint of the first expression. And that first expression was x plus 2. Now, if you recall, it had if x is less than 0. So for the if, I'm going to hit the division symbol. And then we're going to put in parentheses x. And then I want to put in a less than. And to get to the less than, I'm going to hit second math. And you can see it brings up the test. And so we're going to say less than. We're going to hit enter. Less than 0. And we're going to close our parentheses. And I'm just going to look at the graph right quick just to see if that looks good. Okay, yeah. All right, and I'm going to come back to y equals, and then in y2, I'm going to put in the second expression, which was just x. And again, for my constraint, my if, I'm going to hit the division symbol. And again, I'm going to put in parentheses where x is, and this time it's greater than or equal to 0. So I'm going to hit second math again, which is the test function. And I want a greater than or equal to 0, which is option 4. 0, and close my parentheses. And hit the graph button. Now, in mine, of course, you can see that it's in color. But one thing it doesn't show me is you know what? I just saw something there. Well, I'll go ahead and talk about that. Then I'm going to jump on the other. It doesn't show me an open dot and a closed dot, but I got a feeling I might be able to do that. I'm going to experiment here. It's going to run a little bit longer. So I'm going to go back into the y equal, and I'm just going to clear this portion. So I'm going to go x plus 2. And I'm going to hit the division button. And I'm going to go back into the test function. I see that conditions there. Let me take a peek at that. Okay, so I could have then x is less than 0. So I could choose option 2. This is using may need to put that in parentheses. We'll go back and insert the parentheses. There's an app that you can use, which is Inequalities app, and I saw that it was turned on when I went in there on this calculator. Usually you have to turn it on, but it was already on. I've probably used it for something else. Let me see what the graph looks like right now. I was looking to see if it'd give me an open dot. And what it does is it comes just a little bit shy of 2. Okay, anyway, that was just an experiment to see if it would somehow show me an open dot, but I don't quite see it. All right, now, here's what we're going to do. We're going to go and we're going to do the domain and the range. I'm going to take a screenshot of this graph, put it on another slide, and we're going to just briefly describe the domain and the range. You might be looking at it right now and think about what is the domain and the range of this particular piecewise function. So here we got our graph back up from what we graphed, x plus 2 when if x is less than 0, and just x if x is greater than or equal to 0. And remember now, we should have an open dot right here, and we're going to have a closed dot right here. All right, so let's think about it. Moving along, thinking about moving back and forth across the x-axis for the domain. Do I see any values of x that this piecewise function, could not equal? Well, I mean, right up here at the top, it couldn't equal 2, but in the second part of that piecewise function, because it was greater than or equal to 0, it does equal to y equals 2 right here. So I don't see any restrictions on the domain. So we can then say that the domain is equal to all real numbers. Now, what about the range? Well, it looks like on the as y is moving in the negative down the vertical axis, down in this direction here, it looks like it's headed out to infinity. And up here, it looks like y is headed out, negative infinity down here, and negative infinity, positive infinity up here. And I don't see anything that y could not equal. So the range also is all real numbers. Now, that won't always be true, but hey, when it's easy, we'll take it. Now, here's the thing. You got to practice. Now, piecewise functions, and particularly greatest integer functions, which we really just get exposed to. But piecewise functions appear periodically. And the more you practice, the more you're going to be able to remember the keystrokes to do it. Or at the very least, it would just take a quick refresher to remind you how to properly graph these on this calculator. If you do it just one time, come back a month later, I guarantee you're not going to remember it all. If you've done it a few times and you come back a month later, you might need just a real brief refresher, and you go, oh yeah, I remember. Okay, I got it. Practice.